Okay, in this video I'm going to show you how we do two compass straight edge constructions, which compass straight edge, you only need two tools. You need a compass, which makes circles. That's how we're going to get segments of congruent length using radii concepts, and straight edge is how we just use to connect points to make segments. Okay, so the first construction I'm going to lead you through is how to construct a line of reflection given a preimage and an image. And then also I'm going to show you how to construct a reflection point given a preimage and the line of reflection. So this first construction, we need to make the line of reflection given a point and its reflection point. This one we need to construct the reflection point given a preimage and a line to reflect it over. Okay? So let's start with the first one. How to construct a line of reflection given a preimage and image point. So here's our compass here, and straight edge is just, I can use segment tools in here. You just use a ruler to make straight segments. Okay, so what we want to do is construct a line of reflection, or if we make a segment that connects these 2 points. So maybe I'll make a segment here. Whoa. Pretty thick segment. Oops. Sorry about that. I'm going to just make this red. And anyways, here's our segment, right? So this would be like a segment that connects a preimage and an image point. Or just given a segment, we want to construct its perpendicular bisector, right? Which would be the same thing as the line of reflection if we think reflections. Okay, so to do that, this is all in the isosceles triangle thought. So what we need to do is we can think about the segment as being the third side of our isosceles triangle, the one that's not of equal length. So what we need to make is either a triangle that points up or points down, but we need to make an isosceles triangle here so that that perpendicular bisector gets constructed here for our symmetry. So what you need to do is we need to take our compass. The pointy end is going to be the center of the circle. That's the point we pivot around. And the pencil end draws our circle. So all that we need to do is take the center part, the pointy end of our compass, put it on one of our endpoints of our segment. Now what we can do is we can create a circle with a radius that is all that we really need is just bigger than half. Like if this was, say, halfway in the midpoint, we would want to make sure that we make a circle that has a radius that's a little wider than half. One nice thing that we can do is just use the other endpoint, right? That's just a nice guide. So what I'm going to do is I'm just going to make a circle centered at one of our endpoints and a radius that contains the other endpoint. Okay, so now what we have here is, based off of this center point, any point on the circle is going to be equidistant to this length here, right? So all that I need to do then is I'm going to take my compass, keep the exact same radius that I had, and now what I'm going to do is make this the other endpoint the center of a circle, and I'm going to construct another congruent circle to the first one because they have the exact same radius. Okay, so now in our construction we have 2 circles here that intersect. The circles, because I kept the radius the same, the 2 circles are equal. They're congruent circles. Okay, so our isosceles triangle that gets formed would be this triangle here. If we think about this intersection point, because that segment that I just put in there is a radius of this circle, and because we had the radius stay the same in both circles, when I make a radius of this right circle, both of these segments have to be the same because we kept the radius the same, and they're both radii of both circles. So therefore, they have to be equal in length, right? So this is now an isosceles triangle. Now that's nice. We know that if we draw from this vertex perpendicular and cut the segment in half, we'll have that line of reflection. But notice that it extends down here, because really that thought is the exact same thing here. If I were to connect this endpoint to this intersection and this endpoint to this intersection, these segments have to be the same as well. And since these segments are the same, then this point right here and this point right here, because it's equidistant to the endpoints, have to be on the line of the perpendicular bisector, or the line of reflection. So where these two circles intersect is where our line of reflection lies. So if I were to connect these 2 points with a line or a segment, that's going to be perpendicular and bisect that segment. Okay, so let's do one more construction, and I'm going to write a list of steps down. So make sure that you get the steps written in your notes, and we'll do one more construction. I won't use these segments. I did the segments in this example to show you the 2 isosceles triangles that we form using that perpendicular bisector concept. This point that's equidistant to the endpoints, and this point up here that's equidistant to the endpoints, both of them have to fall on our perpendicular bisector. Therefore, we just connect those 2 intersection points. Okay, so let's try that again with some steps written out. Okay, make sure you pause the video and get these 4 steps here of how to construct the line of reflection or perpendicular bisector of a segment. Okay, so first step says here, if we're given 2 points, then we need to connect them with a segment so that we have the segment that we're going to bisect perpendicularly. So here's my segment. Alright. Okay, step 2. Make a circle with center on one of the endpoints and radius so that the other endpoint is on the circle. I'm going to grab my compass tool to make my circle. I'm going to put the pointy end on one of the endpoints, and then I'm going to make my radius. Really, all I have to do is go over halfway. I say use the other endpoint just because it's a nice guideline to have there, but we don't have to by any means. Even though my steps say to do that, I'm just going to show you that we don't have to. I'm going to come in a little bit. Okay, so now I'm going to make my circle. But the trick to the construction is we got to keep that radius the exact same. Both circles have to have the same radius. So now what I'm going to do is just move my center to the other endpoint. Make sure the radius stays the same. If it moves on you, just remeasure it with the circle that you made and make a second congruent circle. So now our construction is really done. All we have to do to make that perpendicular bisector is connect the 2 intersections of our circle, which would be like this. Doesn't want to put it exactly, but which would be something like right here. Okay, so there's our perpendicular bisector. Okay, and that's all that we have to do when we want to construct a perpendicular bisector or line of reflection. Okay, second construction that I want to lead you through is now, what if we had a point that we want to reflect and we have a line that we want to reflect over? Where's that reflection point going to go? Okay, so what we have to think about is reflections have that isosceles triangle look going, right? So if I put a point on the line of reflection, say this point right here, okay, I know that the distance that this point is to point P has to be the same distance that this point is to our reflection point that we're going to make, right? So there's an isosceles triangle concept going on here. So what I need to do is take my compass. I'm going to center it on that point that I put on the line of reflection. And now what I'm going to do is change my radius of my compass so that it contains that preimage point. Okay, so now that I have that, I have my center on the point on the line of reflection. I change my radius of my compass so that the pencil or pen is on the preimage point, and I'm going to make a circle. Okay, pretty thick circle there. I'm going to make that a little thinner. Okay. So we made our circle there, right? So what we know right now is that this distance, and I'm going to draw some extra segments just to show you the construction. The distance this point is from point P has to be the same as its reflection point, right? So we don't know exactly where this point's going to go, but we do know, because of circle properties in radii, that reflection point has to fall somewhere on the circle here. Okay? Well, let's just repeat the process with another point here, and I'll show you what I mean. So I'm going to put another point on our line of reflection, a second point here. Make it stand out a little bit. Maybe this point right here. Okay, so now what I'm going to do is the exact same thing. I'm going to center my compass so that it is on the point on the line of reflection, and I'm going to change my compass now so that it's on that preimage point again. When I have that set up, I'm going to draw my circle again. Oops, and I need to change that thickness. Change that thickness, so there we go. Now we know that this radius, which doesn't have to be the same as this one, this radius here that goes from the center to point P has to be the same here. And notice when we draw both circles here, we have an intersection that is going to be that reflected point, because this radius now is congruent to this radius, and this radius of the red circle now is congruent to the other radius of the red circle. So what we have now is congruent, congruent. These are congruent to each other, not necessarily congruent to these other two. But we have two isosceles triangles made, and that means that this point right here is going to be that reflection point of P. It's going to be that other endpoint of the base of our isosceles triangles. Okay? So let's do another construction. Again, I have the steps written out. Make sure you get the steps written down, and we'll do the construction going through the steps one more time just so that you can see that with no segments in our construction. Okay, so again, in our notes here, please make sure you pause the video and you write all these down. Step 1 says place a point or use a point already existing on the line of reflection. Sometimes we have points already on the line of reflection. We can just use those. We just need any point on the line of reflection. So this example doesn't have any. So again, I'm just going to grab my pen here and I'm just going to put a point like that red one. I'm going to need, well, I'm just going to follow the steps. So place a point on the line of reflection. Done. Make a circle centered at the point on the line of reflection and has a radius so that the preimage is on the circle. Okay, so I'm going to make a circle so that I move the center on that point on my line of reflection, and I'm going to change my radius so that that preimage is going to be on the circle there, right? Okay, so now I need to make sure that this isn't going to be thick, and now I believe I can make my circle. There we go. Not a thick line there. So there's my circle that I made, centered at the point on the line of reflection, goes through the preimage point. Step 3, pick another point on the line of reflection and center a circle with that point and make circle have a radius so that the preimage is on the circle. So same thing, just grab another point that needs to be on the line of reflection, maybe this point right here. Okay? And maybe I'll make it green. So this point right here, okay, so all that we have to do then is center our compass on that point on the line of reflection, change the radius of our compass so it will include or touch that preimage point. When that's satisfied, make a circle, and where those two circles intersect will be that reflection point. So this point right here, where the two circles intersect, will be our reflection point, and we'll call this P prime. So that's how we construct a reflection point given a preimage and the line of reflection. So two different constructions. Your turn to get a little practice with those. Thank you.